Okay, okay, guys. So this video is going to give you an introduction to Kubernetes. So we're going to be talking about. Okay, guys. So this video is going to give you an introduction to Kubernetes. We're talking about. Okay, guys. So this video is going to give you an introduction to Kubernetes. We're talking about. Okay, guys, so this video is going to give you. Right, so we are back. Today we're going to talk about Kubernetes, container orchestrator for microservices. So, what is Kubernetes? Kubernetes is one of the most consequential tool when it comes to the career of a DevOps engineer. We build applications, we run those applications on some environments in the cloud. So Kubernetes is considered to be an operating system of the cloud. Why do we get to Kubernetes? We got to Kubernetes because of the problems that we have with Docker. If you take a look at my screen, you will see that I have here a banking application for Chase. I have this other link that's banking application for Chase. If you look at the URL here, it says chase.com/business, right? You see all these pictures, you see all this fancy stuff. Now, let's assume that behind the scene, this application, this web application for this Chase Bank was built using microservice technology. Now, basically, if you look at it here, we have three services. We have the personal service, we have the business service, and then we have the commercial service. And each time you click on the icon for each of those services, it takes you to a new page. It opens a new page like this to tell you that these are independent runnable services. Behind the scene, this can be built with different programming language. So you have different images for personal, different images for business, and different images for commercial. So how do we get into Kubernetes? Because when we containerize applications, we run them as Docker containers. So a Docker container is simply an application that has been packaged in the form of a running image. In that Docker image, you have the application source code and its dependencies. The reason why we package applications in the form of images, it makes it easier for transportation, for deployment, scalability, and a lot of other advantages that we are going to discover in subsequent videos. So in this Docker container, we have a Docker image that is running inside a Docker container. That Docker image has application source code inside, like a wrapper. Okay. Now, what happens when you run the image? You have a Docker container, and this Docker container, of course, needs some compute resources in order for it to function appropriately. That compute resources can be provided by an EC2 instance or whatever server you can have. So in this case, let's assume this Docker host is an EC2 instance. The Docker container that runs here is an app. Applications are built to process data for some specific function. It can be imaging, it can be video call, it can be texting. And we all learned that for any data computation to happen, we need compute resources like CPU and RAM. We need CPU and RAM. Now, where would the Docker container obtain the CPU and RAM that it needs in order for it to process the data that constantly comes into the application system? It gets that CPU and RAM from the underlying Docker host, which is an EC2 instance in our case. In our case. So this Docker container here has an IP address. We learned that the IP address of Docker containers are obtained from an embedded DNS. There's an embedded DNS server that comes in once you install Docker on a host. That embedded DNS server is responsible to dynamically assign IP addresses to Docker containers once they are spun up. But looking at some characteristics of a Docker container, like the container network interface, right? We realize that containers are very vulnerable, they are very fragile. If the application that runs inside a Docker container exit, the container all itself exit. So I'm saying the container all itself exit. So that makes the container very vulnerable. Imagine you're serving users, right? And those users, their traffic from their browser is reaching a containerized application that is run in the form of Docker containers. If any of those containers was to exit, then let's say we have two containers that are powering the application. Now, if one of the container exit, it means only one container is supplying, is powering the application. You are going to notice the slowness in the application response. You are going to have high latency. You're going to have high latency. Why? Because you have less containers processing traffic coming in into the application. Now, what happens? Because of these vulnerabilities and these fragilities for Docker containers, application developers started to think, what other tool can we use in order to build a sophisticated, highly available, highly resilient application? So, therefore, we landed into Kubernetes. We landed into Kubernetes. Now, with Kubernetes, another problem that Docker container here has is that if for some reason this container goes down and comes back up, the IP address of the container is going to change. Whenever we talk of DHCP, Dynamic Communication Host Protocol, it's when IP addresses are dynamically assigned to devices on a network by a DNS system. So if this container goes down and comes back up, it brings up a new IP address that disrupts communication among containers. And Docker could not resolve this problem. This was one problem where we had in Docker where a container goes down, it comes back up, it disrupts microservice communication. Containers are also very fragile. If something happens to the application inside and the Docker container exit, that container does not have the capability of self-healing. There's no self-healing capability. There's no self-healing capability in containerization system. So if you start your application with two containers, and for some reason the two containers exit and it dies out, you are going to have out of service. There's no mechanism or system in place that is capable to resurrect the container so that they continue to process traffic coming into the application. That's another problem that we had with Dockerization, using only Docker. Now, what is some of those? There are so many other problems that Docker has that Kubernetes tries to solve. So, how is Kubernetes going to attempt to solve some of those problems? Now, with Kubernetes, it is considered to be the operating system of the cloud. Kubernetes is considered to be the operating system of the cloud. Why do we call it operating system of the cloud? We learned in Compute 101 that in a computer system, we have a hardware like this, we have a software on top of that hardware, and then we have applications, we have apps. We have apps on there on the soft on the operating system. So this is your operating system, this is your hardware, this is your hardware, and this is your app. Now, why do we consider Kubernetes to be operating system of the cloud? This translates to the, let's say for example, AWS infrastructure, the hardware, EC2 instances, S3 buckets, RDS instances, load balancers, all those things goes on that hardware like infrastructure. Now, if you sandwich Kubernetes inside here, therefore means that these apps are going to be running in the form of Kubernetes pods. So if you put a Kubernetes pod, the Kubernetes system itself and the cloud infrastructure on which that Kubernetes is running, it is looking upon as a computer as well, where the operating system is Kubernetes, the hardware is the AWS infrastructure like the worker node, and then the applications are pod. If you look at your mobile phone, it looks like this, something like this, mobile phone, sample mobile phone. Let's take an example of an iPhone. On the iPhone, you realize that there's no button on the screen. You just have a touch screen, right? So you have so many things here. It looks like this. This is how your phone looks like. You have so many apps on your phone. So many apps on your phone, like this, like this. I'm just going to draw a couple of them, like this, and like this. Now look at your phone. All of those apps on your phone are doing specific function. This app here is not performing the function of this app. If this app is your WhatsApp and this is Telegram, you cannot replace WhatsApp with Telegram. WhatsApp is built to function differently from Telegram. They might have similar functionalities, but all the apps on your phone are independent. You cannot have two apps of the same series on your iPhone or on your Android phone. Look at your phone. If you have like about nine applications on your screen, those nine applications are doing nine different things. So if you look in the perspective of Kubernetes, that is how your phone looks like. The hardware that you feel and touch is like the AWS infrastructure, like the Worker node. Then the iOS, Internet Operating System, which is the operating system of Apple, is like your Kubernetes. Okay. Then those apps that you see sandwiched on your screen are pods, Kubernetes pod. Now, what are some of the technicalities that Kubernetes is resolving in Docker? Let's pick one of them and explain. The fact that when Docker containers exit, they come up with a new IP address, disrupt microservice communication is a big problem. So when we go into the world of Kubernetes, we are going to take this same container that you see here. This is our Docker container. This is our Docker container. But Kubernetes as an orchestrator is not able to orchestrate. Orchestrating means managing the life cycle of this containerized application. If the application needs CPU, you orchestrate the provider of you orchestrate Kubernetes orchestrate providing CPU. If the container needs more memory, Kubernetes orchestrate container needing more memory. If the container needs to scale, Kubernetes orchestrate the scaling feature of that container. So the life cycle of this container becomes the property of Kubernetes. That's why we call it the orchestrator. It is a container orchestrator tool which we use to deploy microservices. It can scale, it is very secure, it is very resilient. Kubernetes is one of the most important tools that you see in any job. Once you learn this course and you get a job, the probability that you see Kubernetes in your job is almost one. So you can't escape Kubernetes. Now let's go back to the technicalities. This is a Docker container as you see in this square box. In that Docker container, a Docker container is simply the running state of a Docker image. So this is the image inside. Now, for Kubernetes to orchestrate this application, it needs to wrap this container into something called a Kubernetes pod. You wrap it like this, it creates something called a Kubernetes pod. So the first Kubernetes layer on top of the container layer is the pod layer, which is this pod. Okay. So this is like a namespace. It's like a virtual space where the application runs. This is the Kubernetes pod. It wraps this container inside something called a Kubernetes pod. A Kubernetes pod can have multiple Docker containers, okay? But for most case scenarios, you have one container per pod. So it wraps this one into a pod, and then let's say we have another container here. In that container, we have an image. It also wraps that container into something called a pod, like this. Now, because Kubernetes is very intelligent, it knows that if you wrap the first layer, the first pod layer on top of the container layer behave as the container layer. So that means that if we stay here, if something happened to this container inside this pod exit, this pod also dies. Now, this pod dies, but it can be resurrected. This pod can be resurrected by the workload controllers that Kubernetes comes in with. There's something we call workload controllers in Kubernetes. We have three workload controllers in Kubernetes. We have the deployment controller, we have the stateful set controller, and then we have the daemon set controller. These are workload controllers. They are very high level intelligent controllers that they can sense that a Kubernetes pod went down and then bring back that same pod up and resurrect that pod and make sure that this application is always highly available. So because of those controllers, Kubernetes is solving the problem where if a container exit, then it comes back up. It cannot even comes back up because there's no self-healing capabilities when you're dealing with containerized application without Kubernetes. So what does Kubernetes do again? After wrapping this container into something called a pod, it creates another object called a Kubernetes service. So we're going to talk about API object a lot here. It creates another object called a service. Then it places that service in front of the Kubernetes pod. This is a service. It's also an object, independently deployable object in Kubernetes called a service. Then this service is going to be feeding this Kubernetes port with network traffic. So traffic does not go straight to the Kubernetes port, it goes via a service. So this service here is going to be having a static IP address. I'm just going to give you high level summary. There's a lot that can be unpacked in the Kubernetes architecture. So this when Kubernetes create a service API object, that service API object has a name mapping to a static IP address. So whatever happened, the life cycle of a service is separated from the life cycle of the Kubernetes pod, which that service is feeding with traffic. So why is Kubernetes creating another object called service and then place that object in front of a Kubernetes pod? It's because Kubernetes knows that if I don't do this, whenever something happens to the container inside this pod and this pod exit, we are going to have service outage. We are going to have service outage. So what happened? Behind here, you can have multiple ports that one service is controlling. So if you look at it carefully, with your knowledge of AWS, we see that services are acting like load balancers. Exactly. So if you look at it, this one service can be feeding these two Kubernetes port like this. Okay. Now, the traffic that reaches the port is being controlled by this service object. So if this Kubernetes port goes down and comes back up, it does not alter communication because communication is happening at the level of the service and not the level of the port as it is done in Docker. In Docker, communication happens at the container layer. But in Kubernetes, communication happens at the service level, which is a separate object. Separate object. Now, apart from having this thing in place to solve the problem, Kubernetes brought in these controllers that we call deployment controller, stateful set controller, daemon set controller. Those controllers now will create API object like deployment API object, stateful set API object, daemon set API object. We're going to learn what each of these API objects are doing. What is the use of a deployment API object? What is the use of a stateful set API object? And what is the use of a daemon set API object? When would you go with deployment object? When would you go with stateful set object? And when would you go with daemon set? So you have to know, a DevOps engineer needs to know when to use which of these controllers in your deployment strategy. And the answer will base on what kind of application are you trying to deploy. Because all these controllers are doing is wrapping this port into a union. This can be called a deployment union. And then orchestrate and manage such a way that at any point in time, little t, there's always going to be a fixed number of ports in that union to ensure that traffic is always going to be processed whenever it comes in from the service that sits in front of those deployments. So we're going to unpack a lot of stuff here. Now, taking Kubernetes to a next level, we want to slice Kubernetes into 3 layers. Okay, we want to slice Kubernetes into 3 layers. So we're going to look at layer 1, we're going to look at layer 2, and then we're going to look at layer 3, layer 3. So we are going to translate it to plane. We have planes. This is a plane, and we have a plane, okay, and then we have a plane. At a higher level, Kubernetes is divided into 3 main planes. You have the infrastructure plane, you have the infrastructure plane, okay, you have the infrastructure plane, okay, and then we have the Kubernetes plane, we have the Kubernetes plane, we have the Kubernetes plane, and then we have what? We have the workload plane. We have the workload plane. We have the workload plane. This is it here. Now, somebody will ask a question. When you say plane, when you say infrastructure plane, when you say Kubernetes plane, when you say workload plane, what do you mean? If you understand Kubernetes as a DevOps engineer from this perspective, you are going to have a very powerful ability to diagnose a cluster issue at the enterprise level whenever something goes wrong. Most engineers, they fail in the sense that when something is wrong with the Kubernetes cluster in an enterprise, they just go in there and be troubleshooting blindly. Okay? You don't troubleshoot blindly. If you know the differences between each of these plane and something goes wrong, you will know exactly if that problem resides on the workload plane or on the Kubernetes plane or on the infrastructure plane. A typical example is a node being offline. A node is not reachable. A node is not reachable. In the Kubernetes world, a node, which is the infra, falls under infrastructure plane. You will not go and be checking port matrices, checking Kubernetes. No, you have to check the node. It's an infrastructure. If a port is not running, a port is crashing, pod, that port falls under workload plane. So you already know exactly where to go and be troubleshooting. An example would be this. You are working, suddenly you receive messages or maybe some Slack notification that a port went down, a port, certain port are crashing, right? You will not go and be checking the load balancer, checking the RZ database because port are crashing. The first thing you do is you will get connected to the Kubernetes cluster and then you start issuing kubectl commands to query the API server that helps you to interact with this API object. Because you're going to be a well-trained, rounded engineer. You know exactly where to go when something happens. Now let's take a look at this infrastructure plane, this Kubernetes plane, and this workload plane. For me to do that, I'm going to take you a little bit into Sublime Text. Okay, so I want to look at Kubernetes. In Kubernetes, we abbreviate it to be KAS. Okay, this K8S just means that between the word K and S, there are 8 letters: 1, 2, 3, 4, 5, 6, 7, 8. So if you count between K and S, there are 8 letters. So that's why we abbreviate it Kubernetes, K8S. Okay, so Kubernetes plane, Kubernetes planes, for example, Kubernetes planes. So we said we have the infra plane, which is the infrastructure plane. We have infrastructure plane. We have the we have the Kubernetes plane. We have the Kubernetes plane, and then we have the workload plane. We have the workload plane. Now, these things are sandwiched together. It's not like they are separated, they are sandwiched together. Just as your phone is sandwiched. Because when I mean sandwich, when you look at your mobile phone, it has a hardware, which is the case of your phone. Then inside that, if the phone is Android, it has an Android operating system. If the phone is iPhone, it has iOS operating system. Then you have your WhatsApp app there, your Bank of America app, your Chase app. So that's a sandwich. Those are three systems put together to create a computer. Okay. So on the infrastructure plane, what are you going to find? You're going to find the cluster what? The cluster nodes. The cluster nodes are going to be on the infrastructure plane. Those are the most important things that you see on the infrastructure plane. And then the cluster node is going to be further divided into three. You have master node, you have master node, and then you have worker nodes. You have worker nodes. We're going to learn what is master node, what is worker node. Then on the Kubernetes plane, this Kubernetes plane are constitute of systems that are sandwiched over the infrastructure plane. So under Kubernetes plane, we're going to say Kubernetes component, Kubernetes component on the infra plane. It's going to look some kind of dicey, but you're going to understand as we go. Kubernetes component on infrastructure plane. Now you come here, the first one, you're going to say master, master node, master node. So what are the Kubernetes plane component that when you abstract it, they sit on the master node? One, you're going to have the API server, the API server. The API server is there. You also have the kube scheduler. You have the kube scheduler. The kube scheduler is also there. The kube scheduler is there. You have the kube control manager. You have the kube control manager, control manager, and then you have the etcd data store. You have the etcd data store, etcd data store, data store. So this 1, 2, 3, 4 are Kubernetes components that resides on the master node. Now, you also have other components that reside on the worker node. So if you come here, I'm going to say worker, worker nodes, worker node. So question will be, what are the Kubernetes components that reside on the worker node? If you look into a Kubernetes cluster from angle 90 from the top, like you look on top of a table, you see the port, then after the port, you see Kubernetes layer after Kubernetes layer before you see the infrastructure at the back. So now, what do we have? Under the workload plane, you are going to say you have the kubelet. You have the kubelet there. What you also have there, you have what? You have the kube proxy. You have the kube proxy also there. And then you have the container runtime. I'm just picking the most important thing that we need to know as beginners. Container, container runtime. Or you can see, you can be container D or Docker. You can even use Docker for container runtime. Docker. So you see, these are just high-level component, Kubernetes component that are on there. Nodes, which is master node, you have API server, the kube scheduler, the kube control manager, etcd data store, and then on the worker node, you have the kubelet, the kube proxy, container runtime, Docker. Then on the workload plane, what do you have on the workload plane? On the workload plane, you are going to see ports. You're going to see Kubernetes port. Kubernetes ports, and I'll just keep it on Kubernetes port. That's what you find on the workload plane. Now, those ports now are the smallest Kubernetes API object. So you're going to look at deployment and all of that. Now, we are going to further break it down. Okay. Inside this kube control manager, we are going to learn what is the function of the API server, what is the function of the kube scheduler, what is the function of the kube control manager, what is the function of the etcd data store. Okay. Now, next, what are we going to do? This kube control manager is a very important component of Kubernetes because it contains a stack of controllers. Those controllers are used to control the life cycle of the API object, which are necessary for the Kubernetes functionalities. So Kubernetes has a lot of API objects that it deploys into your cluster that helps you to manage your application. But now each of those cluster API objects, they need to have their controllers. Those controllers are there to ensure that that object is working as expected. Now, all the controllers are residing in the kube control manager, except some of them like ingress controller. Okay, so now let's come here. If I do this, I want us to elaborate what are some of the controllers that we can see inside the kube control manager. I will not exhaust the list, but I will say port controller. We have port controller. Under this one, we also have deployment controller, deployment controller. Then here we have what? We have service controller. We have the service controller. Service controller. Okay. Here we're also going to see config map. You're going to have a config map controller. Config map controller. You're going to see secret controller. I will not exhaust the list because there are a lot of them. Secret controller. They are going to see, RBAC controller. We're going to see RBAC controller. They are going to see network, network policy, network policy controller, network policy controller. You are going to see, you are going to see, which one can we use? Network, you are going to see persistent volume controller. I will just say PV controller, PV controller. You are going to see PVC controller, persistent volume claim, persistent volume claim controller, persistent volume claim controller. You are going to see role controller, okay, role controller. You are going to see role binding controller. That will just say etc., because there are a lot of them. etc. So inside this kube control manager system, you have all of these controllers and many more, and many more. Now, these controllers, what are they used for? Each controller is used to control an object. For you, as a beginner for Kubernetes, how do you know which object is being managed by what controller? Just look at the name of the controller. If I say port controller, it means it manages port. If I say deployment controller, it means it manages deployment. If I say service controller, it means it manages service. If I say config map controller, it means it is managing config map. Very simple. No complication there. Very simple. Okay. So those are the roles of those controllers. Okay. Then these kubelet here are used as messengers for your API server. A kubelet sits in the worker node. Those kubelet are there to constantly send messages to the API server because the kubelet continuously feed the API server with information from worker nodes. So the kubelet is like the agent of the API server. The kube proxy is ensure that ports are communicating appropriately. Container runtime is ensure that Kubernetes is capable to connect to a doc to an image registry and pull down images for deployment. The API server is the entry point to the Kubernetes cluster. It receives the traffic via a post HTTPS. When you do kubectl get something, you post that information to the API, so the API server performs authentication and authorization, and it determines if it should grant you access or not by talking to other controllers. So the API server is the master for every Kubernetes cluster. Whatever traffic. Now, somebody will be like, okay, so do you mean that when a user using a product like Chase Bank app, they sense the traffic from their web browser, does it go through the API server? The answer is no. API server only received traffic from the kubectl client. Why? Because you need the cluster certificate, you need a cluster config file for authentication. But the user do not have cluster config file because they don't know it. So the traffic I'm talking about that goes to the API server is traffic coming from the kubectl client. Okay. The kube scheduler is there to make sure that it schedule port so that port can run on different node based on resource availability. If you don't specify any node affinity or node name, whatever, pinning the port on the node, the kube scheduler is going to make a determination dynamically on which of the node in the cluster should the port be deployed to. Okay, so this is just a high level brief of explanation of the Kubernetes system itself. There's going to be a lot which we are going to unpack. Now I'm going to take you back to my drawing board. Let me take you back to my drawing board. On my drawing board, I'm going to use a two worker node, one master to explain. So if you look at this here, this is, and again, this is not an enterprise cluster. But what the one we are going to demo or we're going to provision here is going to be an enterprise cluster. Here we have the master node, which is denoted by M. And then here we have the worker node. I'm going to use two worker nodes, N1. Then I'm going to come here, I'm going to have N2. I'm going to have N2. N2. Now, on this master node here, you have that API server, right? You have that kube scheduler, I'll give by KS. You have the control manager by KM, and they have the ETD data store. Again, this ETD data store is not used to store application data. It is used to store data about the cluster. So it is used to store data about your Kubernetes cluster and not data of your application. Data of your application, you need to figure out something else for that purpose. And because Kubernetes has a lot of there's like a virtual cluster within a cluster. All of these things are in a namespace called the kube system namespace. To tell that as a Kubernetes system namespace, kube system namespace. That's where you have all this stuff deployed into. Automatic when you set up a kube ADM cluster. Now, let's just assume that we have a user. We have a user of our cluster. Yeah, I'm going to type user. Okay. This is a laptop here. Bring this laptop here. Now let's bring this way. This is a user. That's your laptop. Then I'm going to select a user. That user is going to be an authenticated user. Kubernetes, you have to make sure security is there. It's an authenticated user. Now, on this laptop, you have kubectl installed. You have all the requirements. There are so many requirements you need to have on this laptop for this user to be able to query this Kubernetes cluster and then see something displaying on their screen here like that, on their screen. Now, this is the API server. Here you have the kubelet. I will denote kubelet by KL. Keys the kubelet. You have the kube proxy by KP, and you have the container runtime by CROT. CROT. And the same thing you have here, you also have the same thing here. Now, let's say you have installed your kubectl client on this machine. Each time you set up a Kubernetes cluster, it gives you what we call a cluster config file. That cluster config file contains a certificate authority certificate, which is used to sign and authenticate what user is able to talk to the API server. So once you provision your cluster, it creates that config file. That config file is what you are going to set up in your local machine and using the kubectl client to query the API server. So a typical example is going to be, for example, kubectl. I'm not going to write too much here. kubectl get, let me just say kubectl get port, but port can be denoted by PO hyphen N. Let's say dev. There's a namespace called dev in that cluster. When you run this command, again, provided you're on an enterprise cluster, you have to think about VPN, you have to think about if there's any proxy between your client and the API server. You have to make sure that proxy URL is also added to your kubeconfig file, and all those requirements, make sure they are there. When you hit kubectl get port, that traffic is going to be encrypted using your kubeconfig file, and it's going to travel to there. You're going to go to the API server. Now, when it comes to the API server, the API server does two things. It checks for authentication. Authentication is to answer the question, who are you? Okay, who are you? How does the API server knows that this person issuing this API call is allowed? Because the config file that you have in your local machine here was generated from the API server, from the cluster a certificate authority. So the API server now will say, okay, if the traffic coming from this client is sent by someone that I'm aware of, is going to authenticate you. But after authentication, it has to also check for authorization. Are you authorized to do that? Now, the APIs for the API server to check for authorization, that API server is going to send a request. Yeah, inside this Kube Control Manager system, you have the arrow back controller. You have the arrow back controller. The arrow back controller is responsible to manage the arrow back API object like row and row binding. So the arrow back controller that's here is going to check if there's any row and row binding defined either at the cluster level or at the namespace level, and it's going to check if this user is authorized to do this action, which is get, to get this object called port in the namespace called dev. Once everything is certified and the kube control manager gets back to the API server and confirm that this user is allowed to do that action, the API server now then goes to the etcd database and then it reads the information there and then it gives you to the user. That cycle happens very, very fast. But somebody will ask a question. How did the information or how did that data got into the etcd data store? Remember, on all of the worker nodes, you have a kubelet. This kubelet is a service, it's running like a non-native service. So you can use the systemctl utility to control the lifecycle of a kubelet process in the node. So every 5 seconds, this kubelet is going to report the status of the nodes to the API server, like the node, the CPU utilization, everything that has to happen in this node, it keeps reporting it to the API server. Once that information is sent to the API server takes it and then write it into the etcd data store. All the nodes, even if the cluster had 100 or 5,000 nodes, every 5 seconds, all the kubelet on those nodes are reporting to the API server on the status of that node. So that data store is always up to date. And this sometimes you have to encrypt it. There are so many things that we can discuss about the etcd data store, encryption and all of that. So once the data is stored in the etcd data store, then the API server can comfortably read from there and then supply to the user each time you run a command kubectl or kubectl get what or whatnot. So the traffic that comes from the kubelet from the kubectl goes to the API server. But the traffic that comes from end users, look at this, it goes somewhere else. Let's take a look. I'm going to type users here. This is like user on the other side. And if you see, if you're on the left side, it means you are somebody with Kubernetes knowledge because you talk to the cluster using kubectl. But these guys, they open their Android phone, they go to www.showdevops or kubernetes.com/p. They hit that URL, that traffic needs to travel to so many stack before it hits the node. So on this other side, the traffic goes like that. Okay, let me come here. Traffic leaves the end user and then come from this side. Meanwhile, this one other one come from this side for the engineers in the company. So if this guy say complain about something, you come on this other way, you fix it. Okay. So we're going to learn all the different systems that are being targeted before we reach our our worker node in our Kubernetes environment. So typically, that is how Kubernetes clusters are set up. We're going to go through the process step by step. And for this module, we are going to study AWS EKS. We're going to just go straight to enterprise Kubernetes because there's no company, 99% of companies that use Kubernetes, they are using enterprise grade cloud Kubernetes, either EKS for AWS or Google Kubernetes Engine for GCP, or they have Azure Kubernetes Service for Azure. So you are going to meet either of these engines in any company that you go. Very few are still using kubeadm and on-prem Kubernetes stuff. So your experience with enterprise Kubernetes right from day one is going to take you a very long way. So coming now to how are we going to create our Kubernetes cluster, which is AWS EKS. So I'm just going to walk you through the AWS console and they are going to see what we are talking about. In AWS, you have to have your AWS account. If you click on this search bar, you type EKS. If you type EKS, it is Elastic Kubernetes Service. You open it like this. Now, if you look at this, Elastic Kubernetes Service is a regional service in AWS. So it means that when you're talking about clusters, you need to make sure you specify a specific region in which that cluster is provisioned. For now, if you look at my screen here, we are inside US East 2, which is Ohio. There's no cluster running here. If I go to dashboard, the dashboard is empty. There's no cluster running here. So now what are we going to do? We are going to go ahead and provision our Kubernetes cluster. Now, question will be, how are we going to provision our Kubernetes cluster? Now, we are going to continue here. The tool we are going to need, as you guys already know, we have already done Terraform. You are going to use Terraform, which is an IAC tool, Terraform. We're going to use Terraform, which is infrastructure as code, IAC, to set up our Kubernetes cluster. But before that, we're also going to use some AWS services. We need some AWS services like IAM. The most important one I want to talk about here is IAM because IAM is going to determine how you access your AWS from the back end and provision your Kubernetes cluster. I'm going to be sharing two repositories with you. One repository is a repository that will have a fine-grained script which helps you to set up your AWS backend config using IAM role and IAM user. Then the second repository is going to be the repository that contains the actual code for your Terraform, actual code for your Terraform. So what are you going to do once you get those two repositories? Let me show you the two repositories that you are going to be receiving. Now, I will come here. I'm going to change my AWS profile. If you come here on this GitHub account, we have this repository called AWS_access. If I click on AWS_access, it contains assume role.sh. This script is used to assume an IAM role such that an IAM user should not be granted permission directly. In AWS, a better and more efficient way to grant user access is by using roles. A role is an identity that contains a package of permission which can be assumed by a user or other AWS resources to grant you permission to that user or to that resource to carry out other AWS API transaction. So an IAM role can be assumed by a resource. It can be assumed by a user. A user is also a resource. So the role must not be only for an IAM user. The role can be an instance role for a service or whatnot. So there are so many things that can be done. Now, when you look at this script, the script is picking the IAM role from your AWS account, is giving you a session name, and then on the IAM role, you have to make sure that you grant a certain number of hours for the session. This session is to ensure that if my session assumable hour is 1 hour, it means after 1 hour, the stickiness between the user and the role is going to be cut off. So we have our IAM role here, we have the session name, and then once we run this script, it should be able to configure our AWS backend. So once you collect this script, like we have been doing before, you guys already have this, those who are enrolled, those who are taking this course with us, you already have this repository in your channel. So you just go to that repository, and by now you must have had this role defined. We showed you how to craft a role like this in your own AWS account. So make sure that role is properly crafted and you clone this repository, and then you proceed as I'm going to demo on this video. For me, I am using MacBook. So on my MacBook, I will go to my Mac terminal like you can see. I'm going to do clear. Then I'm going to create a folder. That folder, I'm going to call it Cloud Kubernetes. Okay, so I will say make directory Cloud Kubernetes like this. Then I'm going to hit enter. Now I'm going to cd into Cloud Kubernetes. Cloud Kubernetes like this. Okay. Now, if you have VS Code installed on your MacBook, okay, you should be able to just type you should be able to type, you should install the code dot command on your path. So here I do code space dot. What does it mean? It means that I want to open this folder called Cloud Kubernetes within my Visual Studio Code. So when I hit enter, it should open up my Visual Studio Code inside this specific directory. So when I do this, I'm going to do this. Now I'm going to hit Control tilde sign to get this my terminal down here. Now this is my workspace, right? This is my workspace. From here, I want to do everything from here. Now from here, you need to check if you have AWS installed. So if I do AWS dash dash version, for example, I have AWS CLI installed. This is the first step you do. I have to make sure you have AWS CLI installed. And it must have been done from previous module. You study AWS, you study GitHub Action, so you already have it installed. Now, what is the next thing to do? The next thing to do is to go to the two repositories that I shared with you guys. One repository is for AWS Access, the other one is for the Kubernetes itself. So now, what am I going to do? I will go back to my GitHub. This is the repository that has the access. I'm going to copy this one. I will do SSH because this is my account. For you, you are going to use HTTPS because this is not your account. So I'm going to copy this. I'm cloning over SSH. I will come to my local machine, right, on my VS Code. Remember this one. I'm going to do git clone. I'm going to pass that URL like that, paste. Then I'm going to hit enter. Now I cloned the AWS access. That is the first thing I did. What am I going to do next? I will cd into AWS underscore access. Once I cd into AWS underscore access, what am I going to do? If I do ls, I see the script is here, assume role.sh. You can also crack this thing down here. And if you open this, you're going to see that code is here. Now, before you do this, remember you must have done AWS configure with an IAM user without any permission. We did that already. Okay. So what do I do here? I need to test and make sure that there's no loophole. That means when I mean loophole, I mean no IAM user can query the API services for AWS without going through this IAM rule. The way I'm going to test it, I'm going to first of all run AWS sts get hyphen caller identity. This one, caller identity. I'm going to hit enter. If I do this, it means that I'm using a user called infra user as my AWS profile. Now, I want to try to see if this infra user has any sort of permission for anything. The easiest way to test it is by using AWS S3 LS. So if I do AWS S3 LS, now I'm getting this permission denied. It means I'm doing good. This permission denied guarantees you that no one can query your AWS account without having to assume this IAM role. And you have defined who can assume this IAM role under the trust policy of this role inside your AWS account. That is done already. So when you see this message, it means that things are looking good for you in terms of security. Now, the next thing to do now is to execute this script called assume role.sh. I'm going to come here. I will do assume role.sh. I'm going to hit enter. Now, you see what is happening here? I've assumed that role. If I do AWS S3 LS, I hit enter. You still get that permission denied. Why? Because you did this in a script. So there's some sort of batch processing that happen behind the scene that does not guarantee you that the AWS the AWS environmental variables are properly set. So the reason why you're having this error is because the AWS environmental variables are not properly set for that row assumption. So what am I going to do? I will do clear. In this script, part of this script is to spit out a file called AWS underscore temporal credentials. So these are the AWS underscore temporal credentials that that script has created for you. What you need to just do is to source this file so that you can set up these environmental variables appropriately. What do I do? I'm going to say source AWS underscore temp, right? Then I'm going to hit enter. Now, if I run again AWS S3 LS, I should not see any permission issue. Now, it can read and tell me that on my AWS account, I have two buckets. I have the ETEC logs bucket and then I have the EKS observability Terraform state dev bucket. Now, I'm confident that I have successfully integrated my backend to my AWS account. The next step after this is remember, don't forget you have to run cd dot dot. You step back, then you do git clone, okay? You do git clone and then look for the second repository which I'm going to share with you guys, okay? So if I come here, I'll go to then I'll go to repositories. In that repositories, I'm going to type this one here, new EKS IEC. Click on this one. Then I will go to code. I'm going to copy again. I'm going to clone over SSH. Okay. I will then now go to my VS Code. What am I going to do? I'm going to paste it here. Very simple. Paste it. Now I'm going to hit enter. What does happen is I went to my GitHub repository. I cloned my code for my Kubernetes cluster. Now here, what am I going to do? If I do ls here, I should see the two repositories that I cloned. Now I'm going to cd into the new one that I just cloned, which is this one. If I do ls, right, that is the content. Now here you should also try to run Terraform. You must have had Terraform now. Terraform version. Terraform version. You see, it means I have Terraform installed and I have AWS CLI installed. Here I'm going to do clear. Now, on this video, we are assuming that we're not taking into consideration remote backend, state file login. We are just getting our Kubernetes cluster for practice. Now, before you run the code, do a small glance on the Terraform code and see what it's creating for you. Now, under this new EKS IEC repository, we have 1, 2, 3, 4 Terraform files, the TF files, configuration files. Let's take a glance on main.tf. What is inside main.tf? We are defining our region, parameterize it, okay? Now we are reading the availability zones, and then we're also getting a random string for the cluster name. This block here is to ensure that we can create clusters so that we don't have the same name. So we use the random string resource to change the name of the cluster. Now we are making use of the registry module for AWS, which is a package. It's already there. You just have to use it and create your own Kubernetes cluster. So we are slicing the CDI block into three. We're going to have, for high availability, we're going to have 3 private subnet, 3 public subnet. And then we're going to ensure that we also use the EKS module. So we have here the version. So there are certain things we didn't consider here, like separating the VPC from the EKS. Here we are just doing practicals, okay? Now we're getting a version 1.30 for Kubernetes, version 1.30 for Kubernetes, so that during the course of the training, we're going to teach you how to upgrade an enterprise Kubernetes cluster from one version to another without any outage, because it's a very critical thing to do at the enterprise level. So here we're talking about some add-on. We are just picking the AWS EBS CSI driver add-on, and then here we're configuring our EKS managed node group. We're going to learn what is a managed node group. This EKS managed node group ensures that you have worker nodes for your Kubernetes cluster. And the difference between EKS and kubeadm is that for AWS takes care of the master node. You don't have to worry about the master node. You take care all of your worker node. That's why we call it a managed Kubernetes service. Now, if you come here, you have here two. It means we have two managed node group, 1 and 2. Then here you have the minimum size 1, the maximum size 3, and then the desired size is 2. And what happens is once you issue this request, Kubernetes take care of the rest and making sure that you have worker nodes, the AMI type and whatnot. So under the output.tl, what are we printing out? We are printing the cluster endpoint, the cluster security group ID, the region, the cluster name. Terraform.tl, we are defining our version constraint. We are telling Terraform that we are going to need this provider random in order for us to create a random resource. TLS in order to create the TLS resource, cloud init in order for us to initialize our worker node and stuff. So in Terraform, whenever you need to create an object, if that Terraform resource is being created, you must make sure that the provider, which is providing the plugin that Terraform needs in order to create that resource, you must have defined that provider. You cannot try to create a random resource without calling the random provider. It's never going to work. Now here you have the variable.tf for parameterization. If you see on line 7, we are selecting US East 2 for our region to provision our Kubernetes cluster. Very simple file, straight to the point, using modules, nice, cool. Now, what do we do here? I will come here. The first command I will run is going to be my Terraform init. My Terraform init. This Terraform init ensures that I can download provider plugin and initialize my remote backend. Make sure that this thing runs to completion before, if not, you are not going to be able to set up your cluster. So we are initializing our backend. Give it some little time, it's going to run, and then we're going to have our terminal back. That is it. The next you want to do is run Terraform FMT to do some formatting, right? You want to do some linter on your Terraform. Now we're looking good. I'm going to run Terraform validate. Terraform validate. Validation ensures that the code is syntactically correct. Yeah, I'm going to run a Terraform plan. Terraform plan. Terraform plan. This Terraform plan now is to tell me how many resources are going to be created and how many resources. You see, we're going to create 67 resources. So this is an enterprise cluster. 67 resources are going to be created. So you see, once you create this resource with Terraform, you should not change anything by hand. Because if you change anything by hand, when you're trying to tear this thing down to save costs for AWS services, you are going to get wrapped up in a rabbit hole. So if you want to go by the IAC, let's stay clean by using IAC to do any changes. Like for example, if you want to change a region, just come here and change a region and run Terraform apply. Do not change anything from the console. Now, this output tells me that, oh, this my Kubernetes cluster, I'm going to create 67 resources. So what do? I do clear. Next, I'm going to run Terraform apply. Terraform apply like this. I'm going to hit enter. Now, when I want my Terraform apply, it tells me that, okay, I'm going to create 67 resources. Do you want it? You type yes, and then you hit enter. Now it is creating my resources. It's creating my resources. It's going to take some time because it creates a lot of stuff, right? It can take anywhere from 5 to 10 minutes. It all depends. But when you're running it, give it some time so it can go ahead and create your resources. You can go ahead and create your resources. Now we are creating our Terraform resources. While the Terraform resources are being created, I'm going to go ahead and walk you through more concepts when it comes to Kubernetes in AWS. So now, while that is running, let's go back to our dashboard. Let me go back to my dashboard, and then we're going to continue from there. Now, on this repository called new EKS IEC, what do you need to take note of? When you look at the readme.md, it's telling you how to use the repository. You have to make sure that you follow this documentation and then you read exactly what it means. Get started with Terraform. If you don't have anything with Terraform, you can read it. Then now it's telling you that you should have at least Terraform version 1.31 installed locally. Then you should have an AWS account. You should have AWS CLI installed. You should have AWS IAM Authenticator installed. You should have kubectl installed. Then the next step is, once that stuff is done, you are going to create a file called .kubeconfig in your local machine. This is the command here, sudo make directory, you create it. And then you're also going to create a file in there called config file. And then you're going to make sure that you change the ownership of that config file to the user that's currently using your terminal. The reason why you're doing this is because if you don't do this, then you run kubectl get something, it gives you permission issues. Kubernetes errors sometimes are not human friendly. So it's better you know it before you hit those errors, because sometimes you get the error, you might not be able to interpret what it means, right? So you need to run this step. Then once you get this one, the next thing you do is you are going to run AWS EKS. You're going to just copy this command and run it. What does this command do? It reads your Kubernetes endpoint and then it scraps the config file. it throws it inside this config file that you created locally here so that when you run kubectl get info, that cluster, the client goes and reads your config file. So you can run kubectl config view. I'm going to show you some couple few commands once we have our cluster up. Now we're going to be learning and then we're going to be checking our Kubernetes cluster provisioning if anything happens in the back end. So it is still setting up our Kubernetes cluster. So on the repository is very simple. That is all you do. That is all you do. Make sure you follow all the prerequisite steps and you should be able to set up your Kubernetes cluster. Then the next thing I want to take you to, I'm going to go back to my whiteboard. Like I said, on this whiteboard here, we are not provisioning the kind of cluster where the master node is managed by you. No, this is called a kubeadm cluster, or an on-prem Kubernetes. On-prem Kubernetes is where you manage the master node, you manage the worker node. It is very tedious because taking care of the master node and the worker node is a lot of work. So if you go to the enterprise level where you have EKS, we want you guys to be able to learn enterprise skills. So when you go to a job environment, you should be able to help your company to scale. You should be valuable to your job. Now in AWS, we are creating an EKS cluster. We are creating an EKS cluster. And remember, I'm going to open a new board here. Remember, when it comes to EKS, we said that Kubernetes is the operating system of the cloud. So you want to make sure that whatever you are doing, you are thinking of security. You are thinking of security. If I type AWS on my Druid, on my mirror here, you see all of these things here. So you have an AWS, this is AWS region, AWS security group. So if I come here, this is AWS cloud. Okay. Let's check for let's just check. This is the account. So this is the first I bring this one account here. This is an AWS account. So an AWS account, like you guys all know, is like a container of resources. It's a container of resources. So if you come here, this is the AWS account, right? Now, I'm not going to draw a full-scale AWS diagram because it takes some time to do that. But what I'm going to just show you is how you can, let me come here, bring it down a little bit. Now, remember, inside this AWS account, you have so many VPCs. You have so many VPCs. And because Kubernetes EKS is a regional service, right? It's a regional service. You will have to worry about which region am I going to provision in. So if you have AWS, that the next thing you are going to do is you want to get like a region, right? You have region and all of that. So I'm not going to take one AWS region. I'm just searching for the region. Then I'm going to use it here so that you can understand. This is group, this is region, and this is AWS cloud. This is the AWS cloud. I will just skip some of the stuff. I will just take you to a region. You must specify a region, like you see me using US East 2. So let's say there's a region. There's a region like that. Let's specify AWS region. Now I'm going to reduce this thing. We have a region. Now, in that AWS region, because we're talking about deploying application, you have to think about isolation. How do you isolate your workload from other resources? You have to use a VPC. You need a VPC. So if I come here, I go to more shape, I have to type AWS again, AWS again. And then that AWS, we're going to search for a VPC. Then we have here, this is service account, this is public subnet. Okay, this is public subnet, and this is virtual private cloud. So I'm going to bring this one here. And that virtual private cloud VPC span multiple availability zone for high availability. So if I come here, I do something like this, I want to just show you a small picture on how you need to think when you are inside this Kubernetes world in AWS. You have that VPC. And that VPC is going to span multiple availability zone. So I'm going to come and type again AWS, multiple availability zone. So here, this is a region, here's availability zone. Let me say for high availability, I'm just going to use 2 for simplicity. So I'm going to duplicate this one, or I'm just going to use one first. And if you see, look at how it's going to go. Now I'm going to try to change the color for this one to maybe, let me change the color to maybe red. Let me change it to red. Now, it can't be like this. It can't be inside the VPC like this. So you slice it a little bit up and then go past the VPC border and then stay between the VPC and the region like this. Don't go past the region, right? Because our VPC zone is inside a region. So it stays in between this, like that. Then I can add another region again for high availability. On our code, it shows that we have three regions. But for time constraint, I'm just going to do two region, two availability zone. Now let me get the next availability zone, which is this one. I'll come here, okay? I'm going to also, I'll just keep this one blue to make a distinction. Here, I'm going to reduce the size of this to make it small, reduce it more. Then again, I'm going to take this one, I will slice it a little bit like this in between the VPC line and the region line. Then I slice this one up like that. You see that? So now what happened? What does it mean? It means that we have multiple availability zone. The VPC is spanning multiple availability zone for high availability. Then for security reasons, we need to separate internet facing resources and non-internet facing resources. So for you to do that, you need to think about subnet. So I'm going to type AWS. Here, what do I have? I have here private subnet. I have here public subnet. This is the two here. So I take the private subnet, I put it there. Okay. Now this is very big, so I'm going to reduce the size of it, make it very small. Make it very small. Come here, reduce the size. Then for this writing, I'm going to make it very, very small. Let me just make it simple, right? This is a private subnet. Let me put it behind here. Private subnet. And if you see the private subnet, I did not put it outside of the VPC like this. I put it inside the VPC here like this. You see that? So you need to make sure you follow these lines. It's inside the VPC. Now I come back here. I'm going to just take one. I'm not going to draw everything for time constraint. Here, AWS, that's a private subnet. Then here, I'm going to use a public subnet. Public subnet. Just like this. Then I come here. I'm going to reduce this one. Going to reduce this one. Make it very small. Now I'm going to drag it and bring it inside here. I'm going to reduce the writing there to something very small. Something very small. So you see, now look at what is happening here. Per availability zone, we have one public subnet, one private subnet. Per availability zone. That same thing repeats inside this other side here. Now, when you're setting up your Kubernetes system, your worker node should be inside a private subnet, not the public subnet. The worker node should be inside the private subnet for security reasons because you are using some load balancers, some ingresses before traffic reaches that specific. You don't want to put your worker node to be internet facing. You don't want that, right? Because you're exposing your application via some networking resources. So this is just a small explanation to tell you that when you look at an AWS diagram, how do you know exactly how the thing goes? In an AWS account, we have a region. We can have multiple regions. We just use one region. Then in a region, you can have multiple VPCs. We just use one VPC. Then in a VPC to span multiple availability zone for high availability. And you see now that in each availability zone, we have a combination of private subnet and public subnet. In our case, we have three private subnet and three public subnet, but we have three availability zone, one per availability zone. So this is replicated three times. Now let's go back and check our stuff. You see, it takes some time. It is still running. So we're still now it is provisioning our worker nodes. It's provisioning our worker nodes. Very soon we are going to be done and we are going to continue. Now, while it is provisioning our worker nodes, we are going to come back and explain more stuff in our UI. So let me come here. Now, I'm going to come here. I'm going to go to my AWS account. On this AWS account, we're going to type EKS. Now, if I go to Elastic Kubernetes Services, something is already coming up. You see, this is the Kubernetes cluster that has been provisioned using that Terraform. You see that? So the cluster name is this, and then you see the this ending point is created by the random string. The version of Kubernetes is 1.30, and it has a standard support all the way to July 22nd, 2025. So today is July 1st. We just have 3 weeks before we go into extended support. And know that when you go into extended support, you are going to be charged more money than staying in standard support. And the only way you don't get into extended support, so you don't get charged, is by upgrading this Kubernetes cluster from 1.30 to 1.31 before July 22nd. And we are going to use that as another demo to show you a safe way to upgrade that cluster. We don't want to upgrade it now because we don't really have any application running on it. We are going to show you how you can upgrade a live cluster that has application running on it without causing any harm. And what is the upgrade strategy? If I click on this, you see, you have all this, your current IAM principal does not have access to Kubernetes object. That is fine. That is fine. Now, we have something we call access mode for EKS cluster. We have two access mode. If you click on manage access mode, you see that we have EKS API and EKS API and config map. Now, this is a new thing that AWS brought in because when you have only config map, each time you want to grant a user access to the Kubernetes cluster, you also have to update the config map. And you might be prone to errors. You might be prone to errors because if a config map is corrupted, no one can get access and authenticate to that cluster again. So because of that reason, AWS rolled out the EKS API access mode, which is based on IAM. It's based on IAM user and IAM role. You can grant an IAM role access to a Kubernetes cluster. You can grant an IAM user, IAM group. So it's a more sophisticated and more clean way to grant access to users to your enterprise level cluster. So here, if you see by default, if you click on access tab here, these are the default principals. This is the user that is used. This is the service role, the EKS role used by the EKS cluster itself. It has access to the cluster. This is the role, the role on the node. So normally a Kubernetes node should also have access to the cluster because it needs to join the union, without which you cannot join the union. So these are the role for the cluster that is for the managed node. Now, this user infra role, this is a role that was used to set up the cluster. This is a role that we assume in our assume role.sh. So also this role also need access to that cluster for initial configuration. They have multiple other things like OIDC, identity provider, and all of that. Overview is to give you information about the cluster, the API server endpoint, the certificate authority, OpenID Connect provider, the cluster IAM role, and beautiful information. Now, under resources, you are going to see the workloads. You see the cluster, the service. The reason why you're seeing service cluster does not have any port is because the user that I'm currently using to access this cluster does not have those permissions to view Kubernetes resources. And you can see that clearly from this stuff here. Here, I'm signing in with my root user account, but you don't see any root IAM being granted access to the cluster here. That is why you're seeing all this permission deny issue. If I want to fix this, all I need to do is I need to grant this AWS account root user the permission to assume this infra user role, Then once I do that, I switch into infra user role. I'm going to eliminate the issue of that error. That is going to come on a different video. How do you securely grant users access to your Kubernetes cluster without compromising any security? Now let's go and check if our Terraform is still running. Probably it is done. You see, our Terraform is done provisioning. We just provisioned 67 resources. Now we have our cluster endpoint and then we have our region. Everything is there. Now the next thing you need to do is, you're going to do clear. You have to go to your manual. The manual is going to be part of the repository that we're going to share with you guys. So if you look at it here, now I'll come here. I already have this stuff set up. Okay, so you copy this and paste it. What I'm going to do here, I'm going to copy this one. This one to update the kubeconfig file. I will copy this command. Just copy this command. Okay. Then I'm going to paste it on my local machine. And this is not going to be possible if you don't have AWS CLI installed. I hit enter. Now you see, added new context, this to my kubeconfig file. Now if I do kubectl config, kubectl config view, kubectl config view, I'm able to read my config file. I'll do clear. If I do kubectl cluster info, You see, when I want kubectl cluster info, it's telling me that Kubernetes control plane is running at this address. So because this is managed Kubernetes, the master node is managed by AWS. So you see, this is the endpoint to your control plane. Then the core DNS, which we are going to learn more about core DNS in subsequent videos, is going to be there to manage for the DNS activities for the Kubernetes cluster. It ensures that when you create a Kubernetes pod, it does some kind of service discovery and then it registers the information of the Kubernetes pod in the core DNS system so that each pod name should map an IP address. There's something called service discovery, which we're also going to learn during this module. Then for further debug, you can run kubectl cluster info dump and all of that. Now, what I need to run here is going to be kubectl get nodes. I want to check and make sure that my nodes are all running. If you see here, I have here ready, ready, ready. So this cluster has 3 worker nodes that are currently running very well. So once you get to this point, then you will say that you must have done with setting up your Kubernetes cluster. Thank you very much for following this demo and introduction. I'm going to see you on the next video where we are going to start performing some cluster administrative activities. See you and have a nice day.